Okay, so this is our last kind of a review session. So this is going to go pretty quickly. I'm just going to give you a bunch of examples. This is stuff that you've learned in previous classes that I just need you to refresh on. So let's get started. So here we're going to be simplifying rational expressions. And when we think about rational expressions, what we need to think about is fractions. That's really the deal. So let's look at some examples here. We'll start kind of simple and we'll end up pretty complex. So the first one here is x squared plus 4x plus 4 over x squared minus 4. Now, the one thing you need to be very, very careful of and be very sure of is you cannot cancel term by term. Let me even just write that. Cannot cancel term by term. Okay, you must cancel factor by factor. So must cancel factor by factor. So that means when you do any of these problems that we're going to do today, you're going to have to fully factor the problems out. So let's take a look at this first one here. When we factor that numerator, it factors as x plus 2, x plus 2. I will not be going through any of the factoring details. You can take a look back on the first lecture and go over that. I also have provided a PowerPoint example kind of slideshow for you to look at as well if you need to. So the numerator is x plus 2, x plus 2. The denominator factors as x minus 2, x plus 2, because that is the difference in squares. And then we can cancel these term by term. So an x plus 2 will cancel out an x plus 2. Remember also when you're canceling, they have to change levels. So it's either going to be a numerator, denominator. It could also be kitty corner, as you'll see when we do the multiplication. And so our final simplified answer here is x plus 2, x minus 2. We're going to give all of our answers in full factored form, so we won't be multiplying anything back together in general in our final answer. Let's take a look at another one here. We have x minus x squared over x squared plus x minus 2. Okay, so again, we're going to factor each piece here. Well, when we look at the numerator, we do have a square in it, and it's two pieces, and it's a difference, but it's definitely not the difference in squares. So we can pull out an x out of the numerator, and we're left with 1 minus x. And then if we look at the denominator here, it's a trinomial that requires the AC method, and this is going to be x plus 2, x minus 1. Now, when you take a look here, if you know the trick, then that's awesome. Just apply the trick, but just in case you don't know the trick, notice that these two factors here are direct opposites. Negatives of each other. Okay, and when you notice that you have negatives of each other, they cancel out to equal a -1. And so our answer that we'll get here is negative x over that x plus 2. Now notice these x's don't cancel here because the only thing to cancel out an x plus 2 is another x plus 2, and the only thing to cancel out an x is a single x, not an x that's wound up with something else. Okay, let's keep on going. Our next example is 6x minus 27 over 5x times 2 over 4x minus 18. Now, same rule kind of applies here. We've got to simplify each piece, factor it down to its smallest pieces. So our 6x minus 27, the most we can take out of that is a 3, and that leaves us with x minus 9, or sorry, 2x minus 9 over, nothing we can do with that 5x, that is in simplest terms. Nothing we can factor for that 2, it is also in simplest terms. And then here, the 4x minus 18, we can take a 2 out of there, and we're left with a 2x minus 9 as well. Now, when we go to cancel here, we can cancel when they're on top of each other, but we can also cancel when they're kitty corner. The idea is they have to have a change of level. Remember, we could rewrite this whole thing as one thing over the other, and then we would be able to cancel it out as well. So you can notice here that this 2x minus 9 cancels with that 2x minus 9. And then we're left with 3 times 2 is 6 over 2 times 5x is 10x. Ooh, I missed that factor of 2 right there. Could have caught that, but I didn't, so that's okay. I can catch it right here. What goes into 6 and 10 is 2, 3, and 5. So our final simplified answer is 3 over 5x. Let's take a look at another one here. We've got x squared minus 4x minus 12 over x squared plus 2x minus 48 times x squared plus 4x minus 32 over x squared plus 10x plus 16. Now, when I do really big problems like this, I might do each little piece separate, you know, do a left top and a left bottom and a right top and a right bottom and put it all together. But all of this factoring is pretty straightforward. None of it requires any real difficulty here. So let's look at this top left. We have the factors of negative 12 that will equal negative 4, so this is x minus 6, x plus 2. Down here we have negative 48, so the factors that equal negative 48 that add to be 2, that would be 6 and 8, and that is a positive 8, so x plus 8, x minus 6. Times, let's do this piece over here, x squared plus 4x minus 32, that's going to be x plus 8, x minus 4. And finally, our x squared plus 10x plus 16, that's going to be an x plus 8 times an x plus 2. Now, when you cancel, you can only do 1 for 1. So let's just start killing them off. I like canceling the stuff here. So our x plus 6 cancels with this x plus 6. This x plus 8 can cancel with this x plus 8. This x plus 2 cancels with this x plus 2. And our final answer is what's left, which is x minus 4 over x plus 8. Okay, so let's get a little bit more difficult here. Let's take a look at this guy. We have 12x divided by 5x plus 20. All that divided by 4x squared over x squared minus 16. Now what we have here is a complex fraction. We have a fraction divided by a fraction. And what we get to do with that is something called a stay, change, flip. And you might call it something slightly different, but basically the first, the numerator of this really big fraction stays the same, so 12x over, and I'm going to go ahead and factor this. We can take a 5 out here, and this leaves us with an x plus 4. The change means that we're going to go from division, and we're going to change it to multiplication. And then the flip indicates that we're going to take this denominator down here, and this guy gets flipped over. So we have x squared minus 16, which I'm going to factor as x minus 4x plus 4, over that 4x squared. So what we've done here is a stay, change, flip. Top fraction stays, change it into multiplication, flip the denominator over, and then we're just back to where we were before. So we take a look here and see what can we cancel out. Let's see this. 4 can go into 12 3 times. This x can cancel out the square on that x, so we're left with one x here, and we have an x plus 4, cancels out that x plus 4. So let's see what we're left with here. We're left with 3 times an x minus 4 on the top over 5 times x on the bottom. And you would want to leave it in factored form, which is what we have here. You wouldn't necessarily say it's 3x minus 12. Okay, you would generally keep it in factored form, because if we were going to do something with it beyond this, like solve it, we would have to factor it again. So that is generally the practice when you start getting into advanced algebra and math. All right, let's take a look at another situation here. What if we have 5x minus 4 over 3x plus 4 minus an x plus 1 over a 3x plus 4. Now, this you will be doing a lot of adding, adding fractions together. Here our denominators are the same. Remember, you can only add the numerators together. You can only combine the numerators when the denominators are exactly the same. So here we've already got them the same, so we can just go straight to 5x minus 4 minus, and this is minus this whole quantity, x plus 1, all over one denominator because they are the same denominator. Now we'll clean this up here, and we've got 5x minus 4 minus x minus 1 over our 3x plus 4. So this gives us 4x minus 5 over 3x plus 4. Excellent. Nothing factors there. We can't simplify it down anymore. Okay, let's do a couple more examples. Seven over x minus 3 minus 3 over x plus 1. Okay, there's a storm that's rolling through right now. Hopefully this does not interrupt what's going on. Just let you know, if the storm does come through, I'm going to render this video where we are now and then pick up for the last few problems, but fingers crossed. Anyway, okay, so first things first, we have to have a common denominator. It does not have to be the least common denominator. It just has to be a common denominator. So I always employ this trick. We're going to multiply both pieces by what we need to make a common denominator. And keep in mind that if you multiply an equation or a term in an equation by the same thing over the same thing, like 3 over 3, which is a fancy way of saying 1, or x plus 1 over x plus 1, which is also a fancy way of saying 1, then it's just multiplying it by 1. We're using some algebra manipulation here so that we can get the denominators to be the same, because we know once the denominators are the same, we can do the math to put the numerators together. So if we look here, and I'm really not going to belabor how to find the LCD too much. You should have spent a lot of time on this. If you need some more assistance with this, you can look up some stuff. You can holler at me. I will be super happy to sit down with you and help you. Okay, so here, let's just note, I'm going to note what the LCD is, and the LCD is x minus 3 and x plus 1. Those are the only denominators here, so they are multiplied together, the least common denominator. So what do we need to multiply the x minus 3 by? Well, it needs the x plus 1, and what we do, the bottom we do the top, and what do we need to multiply the x plus 1 by? It needs the x minus 3. So now we have managed to get the denominator the same. So now we have 7 times this x plus 1, and I'll clean it up here in a minute, minus 3 times our x minus 3, and it's all over just like our last example, whatever that LCD is, which is just an x plus 1 times an x minus 3. Now, there's no canceling that goes on beyond this, okay? You're going to clean up the numerator if you can factor something out of the numerator and then cancel, yes, but at this point we do not have a situation where anything could be canceled. Notice that this 7 is compromised. This x plus 1 can't be canceled because it is multiplied by 7 and subtracted by this other stuff. So the only way things can be canceled is if those terms or those factors are all multiplied together. So we're going to need to distribute all of this stuff and clean this up. So we have 7x plus 7 minus 3x plus 9 all over that one common denominator that we've just made. And then let's see, 7 minus 3 is 4x. 7 plus 9 is 16 over x plus 1, x minus 3. And because we're factoring completely here, we can pull a 4 out of the numerator and be left with x plus 4. And then the denominator is x plus 1, x minus 3. Okay, let's do another one. And do I need a new? Yes. Let me go to the next slide. I think I need all the room I can get for this next one. Let's take a look at this example. It is, let me look at it from the original because my notes already have it worked out. Let's see. Is this the one? It is. Okay. So x plus 4 over x squared minus x minus 2 minus 2x plus 3 over x squared plus 2x minus 8. Now, notice also that almost all of the examples I'm doing today have got subtractions in them. You will come across them with additions, but I wanted to do the subtraction ones with you so that you could be cognizant of the fact that you've got to distribute those signs through. So my examples have been picked out just to point out some of the little tricks that you might forget about from when you learned how to do this before. Okay, first things first is I've got to factor these guys completely. So this is x plus 4 over, in this denominator, x squared minus x minus 2 is x minus 2, x plus 1. And then minus our 2x plus 3. over, and then this factors out to be x plus 4x minus 2. When we look at our denominators here, our LCD is going to be that first denominator written down completely, plus whatever we might be missing from that second denominator, which is actually the x plus 4 term. Okay, and I'm going to rewrite this just so it's neat for you. And we'll need to multiply this guy by something. Okay, and now we're going to multiply by what we need. And the first one, we need the x plus 4 term to complete that denominator. And the second one, it looks like we need the x plus 1 term. Now, this leaves us with x plus 4 times x plus 4 minus 2x plus 3, oops, that was a bad one, times x plus 1, all over one common denominator, x plus 4, x minus 2, x plus 1. Now, a lot of times students feel compelled to do some canceling here, and you cannot cancel here because all of this stuff is tied up in an expression of subtraction. So you have to multiply it all out, clean it all up, do the whole 9 yards. Okay, so let's see what we've got here. So when we FOIL this, right, that's what you know how to do, right? FOIL. So this guy becomes x squared plus 8x plus 16 minus, and this is 2x squared plus 5x plus 3. 2x squared plus 5x plus 3. Let me double check that. 2x squared, 2x plus 3x is 5x. Okay, just wanted to make sure I didn't actually work this problem. So I just made it up. So let's keep on going. Now be sure that you're very careful here and that everything gets that negative distributed to it. So then we have x squared plus 8x plus 16 minus 2x squared minus 5x minus 3. All over this. Okay, and so now let's clean up the numerator here. We have a negative x squared plus 3x plus 13 all over our x plus 4, x minus 2, and an x plus 1. Now we know that this doesn't factor because what are the factors of 13? It's prime, it's just 13 and 1. There's no way to get a 3, so we're done. You could factor out the negative sign if you wanted to, but this is actually fine. But I'll show the extra step just in case your textbook wants you to do that. So you could factor out the negative here and get an x squared minus 3x minus 13. Oh, what a big thunder boomer. Okay, x plus 4, x minus 2, x plus 1. So just as a weird side note, I moved here last July from Alaska, and I lived in Alaska for about 15 years. Before that, I lived in the Middle East, and before that, Texas. But anyway, In Alaska, they do not have big thunderstorms. We don't have those kind of thunderstorms because of the way that the mountains are and because of the nature of everything up there. And so I do enjoy a good thunderstorm when they do happen. Okay, almost done. Let me try to stay on task here. We got a couple more examples I want to do, and we will be done. Here I'm going to do some truly complex looking fractions. The first one is pretty common. This kind of comes up in a weird way kind of often in calculus and stuff. So let me just show you how to do this. Now what we have to do is we have to consider each piece separately. Okay, so we're going to put this first numerator together. The LCD is x. Don't forget that this is like 1 over 1. So we would really need to multiply this guy by x over the x and this guy by 1 over 1 to put that numerator together. So we would get x plus 1, all that crap, over x. That's that numerator piece, and following along with that, and with this being over 1, we could do this x over x thing and this 1 over 1 thing. And I know that's silly to do the 1 over 1, but I like to make sure everything gets accounted for. I don't really care how you do it, but this is how I'm going to do it, and I'm going to be consistent in the way that I do it, or at least attempt to be consistent. Now we have that complex fraction that we just dealt with before, that fraction divided by that fraction, so we can stay, change, flip. So this becomes x plus 1 over x times x over x minus 1, and so these x's cancel out and we're left with x plus 1, x minus 1. And then I have one final example, and I want to remind you that these first two lectures have been review lectures. So this is not the way that the class will typically go. I will be giving theory. We will have practice problems during the lecture and definitions and all sorts of stuff. It won't just be me cranking through problems, but because I just want to make sure that you're ready for the math, then we're going to start with these two review sections. Okay, so here's the last one. 2 over x plus 1 over x divided by 3 plus x minus 1 over x plus 1. Okay, so we need to handle each one of these separately. We have the exact same situation as we had on the numerator above us here. So if I do this, I'm going to have 2x minus x plus 1 all over x. That's that new numerator, done the exact same way. And then if we look at this denominator, what am I going to have to multiply this guy by is going to be that x plus 1 over that x plus 1, like I had to multiply this guy by x over x, 1 over 1, 1 over 1. So I did it exactly the same way. And so this is going to give us 3 times x plus 1 plus an x minus 1. I didn't need to put it in parentheses here because there wasn't anything to distribute through, but if you want to make a habit of putting in parentheses to drop the parentheses, absolutely do so. Over, and our denominator here is x plus 1. Now we need to simplify each piece here. So this is 2x minus x is x. This becomes 2x minus 1 over x over, I'm just going to write them all out here, 3x plus 3 plus x minus 1 over x plus 1. So this becomes x minus 1 over x all over. And sometimes when I have these complex ones, I just like to darken that middle line up there a little bit. 3 plus 1 is 4x plus 2 over x plus 1. Now we can stay, change, flip. So this is going to be an x minus 1 over x times x plus 1 over, and I see I can factor something out of that, so I'm going to pull that 2 out of there, 2x plus 1. And is there anything that'll cancel? No, nothing cancels. But it's beautifully factored now. So let's get our final answer, and our final answer is going to be x minus 1, x plus 1 over 2x times 2x plus 1. Okay, so hopefully this covered all of the different things that might come up for you in the homework for this section. And this is simply nothing more than just a reminder of things that you already knew. Okay, thanks. Y'all have a good day.